So now let's turn our attention to torsion springs. Torsion springs are very different than extension and compression springs, though they look quite a lot like extension springs because the coils are most often touching one another. There are some torsion springs that are not that way, but it is convenient to have the coils touch each other because it reduces the overall length. And if you think about one of the problems with a torsion spring, well, you basically need to grab a hold of the arms on either end and apply force to them in opposite directions, but since they're offset from one another, that causes a force couple, and that force couple tends to rotate the entire body of the spring. And so a lot of times you operate a torsion spring with a rod through the center of it to prevent it from rotating around an axis that you don't want it to rotate around. So that's very common. There are ways to get around this. For example, if you make a double torsion spring, then you can balance out the forces so that you effectively cancel that twisting moment. But it's still recommended often that you have a rod in between the coils because you can still end up in situations where the spring can go out of plane, and that's problematic. Now, you can have all kinds of end treatments here as well. You see some examples here with short ends. You see hinge ends, straight torsion. There's so many possibilities here. I doubt I know them all or could list them all. So just remember that there's a lot of design flexibility here. But fundamentally, the type of stress that's in a torsion spring is very different than the type of stress that's in a helical compression or extension spring, because instead of essentially taking a rod and twisting it, think about how the torsion spring is made. Well, you take a piece of wire, you wrap it around a mandrel. That doesn't sound very different. Yes, but when you load it, you grab a hold of the arms and you bend them, right? So imagine unwrapping the spring. It's just a bar out. What are you doing? You're bending it as if it's a cantilevered beam. And so the type of stress you're introducing into the material is a bending stress or a normal stress. And so this, you might recognize sigma as the symbol for normal stress. Again, this equation essentially comes from strength of materials, but because we've taken that rod and wrapped it around a mandrel, we need a geometry correction factor, which is the wall correction factor. Now notice that the wall correction factor here still has the symbol capital K, but it's got a subscript for bending, so be very careful. You don't want to use the wrong wall correction factor for the wrong kind of spring. You want to use this wall correction factor for torsion springs and the one you saw before for extension and compression springs. But you can see where it goes into the equation. M is the moment applied to it. Now I was talking about grabbing a hold of the ends of the spring and pushing and pulling on them, but if you think about it, that's a force at a distance from the center line of the body of the spring, and so that is essentially a moment being applied to the torsion spring. So the moment is calculated from the force applied to the end of the arm of the spring down to the center of the body of the spring, and that's how you get the moment. Of course, we've got the wire diameter in here, and you'll notice that the spring index is involved in this as well in the wall correction factor. Now here are the figures I was talking about earlier. You need to tab these also, but these are the design stresses that are allowable for various materials when we're using those materials for torsion springs. So make sure on this tab you write torsion springs only, or normal stress or something, so that you remember this. Now in the body of those two figures, go and contrast the two together, and you'll notice there are some indications. I think that on these he's got a sigma in it. I can't remember, but there is something you could highlight to remind yourself which one to use where. Okay, so you may want to do that so you don't make the mistake of just grabbing the wrong tab out of sheer panic on a test and then looking up the wrong value.